Hello, ladies and gentlemen. Welcome to the demo of our latest product, SimuFlight, a next-generation airport efficiency enhancing software. We are Cathen,
Yasaman,
Gyung,
Willy,
and Soog.
Here's the agenda for today. We will go with the order of market opportunities, product description, airport processes modeling, user interface, and experimental study. Based on our research, there are two trends in the airport industry. Firstly, there's a huge increase in air traffic due to rising travel demand worldwide. Secondly, many countries have implemented new security measures to protect commercial aviation in recent years. The implications of these two trends will lead to longer waiting time for passengers, hence jeopardize the airport efficiency system. Our research also shows that airport managers are most concerned with passenger experience. Total waiting time for a passenger in the airport is the key performance measure that we feel is important to airport efficiency management. Narrowing down to the airport passenger queue problem, we've also identified two common issues that challenge airports. First, there's increasing queue size problem, which is more prominent in the emerging markets. For example, airports in Brazil will be experiencing much higher air traffic due to the World Cup in 2014 and the Summer Olympics in 2016. Second, there is stabilized long queue problem, which is more prominent in the traditionally busy airport such as JFK, San Francisco, and other international airports. As we can see that the demand for airport efficiency enhancement is huge. And now we would like to introduce our product.
As we mentioned before, airports can face two types of problems in their operations. For type 1 problem, airport needs to identify the bottleneck in their system to stabilize the passenger's waiting time. For type 2 problems, airports need to evaluate the statistics on passengers' waiting time to reduce these values. By achieving this, airport managers can obtain their ultimate goal, which is getting a higher throughput for the airport. SimuFlight is a comprehensive software package that provides solutions for both of these problems in order to achieve this goal. SimuFlight does this by collecting waiting time at each stage for each passenger and computing the average total waiting time for different types of passengers. Then, for type 1 problems, identifies the bottleneck in the system by utilizing the user interface. And for type 2 problems, it provides statistics on current waiting time for passengers. These solutions allow managers to determine the number of servers and the service rates according to the desired lower waiting time. Now, we'll go over the process modeling.
Our product models both the departure and arrival processes. First, departing passengers enter the airport and join the line for airline check-in. Then, they join the line for security screening. Finally, departing passengers will enter the line for boarding and leave the airport. For arrival process, the model simulates the flow of arriving and the transfer passengers. After leaving the airplane, arriving passengers join the line for immigration service. Then these passengers go to the baggage claim area and wait for their luggage. Finally, they leave the airplane. For the transfer passengers, after they leave the airplane, they will join the line for their own security screening. Following this, they finally join the line for boarding, which is the same for the other departing process, and leave the airport. Now, we will talk about the user interface of our product.
In our airport model, we take into account different types of servers that airport managers have control over, which includes security agents, the check-in counters and aides, and the departure ID check agents. Next, we move on to the user interface for our model. In this user interface, the user can decide how many of each types of servers to use in the airport. This user interface can also be used to describe the service time of different servers, with each service time requiring 4 parameters. Last but not least, the user can determine how long the simulation runs via the runtime. Now suppose these default values were the inputs we wanted to use. When we click Run Simulation, our airport model runs and produces graphs of the average waiting time. Observing these graphs allows the managers to identify the bottlenecks and the target number of resources to solve the problem. For example, in the first graph, which describes the average waiting time of the passengers in the departure process, shows that there is an increasing queue. But for this last graph, which describes the average waiting time of international passengers, the queue is quite stable, but the problem of long waiting time is still present.
Now we're going to talk about how one can use our product to reduce the waiting time for one type of departing passengers. If an airport wants to encourage passengers to use self-checking machines rather than checking counters, which add a lot of labor costs, it needs to reduce the waiting time for the passengers using the self-checking machines. The following experimental study focuses on the second problem that we talked about. This is the case where the average waiting time for self-checking passengers is assumed to be stable, but its value is larger than its desired level. First, we get the data on servers in the current airport system. Then we run the simulation of the system with our product enough times so that we get the range of waiting time for which 95% of passengers' waiting time fall in. As a second step, we run the simulation several times while increasing the number of servers one at each time to see whether any of scenarios can give their desired waiting time. Let's say we have 2 servers in the current system. If they want those passengers to spend less than 80 minutes in line, only adding 2 of them meets their needs.
Last but not least, we'd like to highlight the tri-pillars of SimuFlight's core competencies. SimuFlight is extremely accessible, flexible, and applicable. That comes to the end of the presentation. We thank you for your time and attention and hope you are as confident as we are for this product. Investing in SimuFlight will promise you a great return. Thank you.